Welcome to GSR Maths Academy. This is our sixth question of exercise 8.1 of similar triangles of class 10. Let us observe the question in the given figure. DE is parallel to OQ and DF is parallel to OR. Then show that EF is parallel to QR. Here if you observe the diagram, in this triangle PQR, DE is parallel to the OQ and DF is parallel to the OR. Now we need to prove that EF is parallel to the QR. So for that, let us write what is given. In the given, I wrote that in triangle PQR, D is parallel to OQ and DF is parallel to OR. Then what is required to prove? That is EF is parallel to QR. So let us see the proof, how I am going to prove it. Here D is parallel to OQ. POQ in triangle POQ. ED is parallel to the QO. D is parallel to the OQ. Okay. D is parallel to the OQ. Now from the basic proportionality theorem, if a line drawn parallel to the one side of a triangle, then it divides other two sides in the same ratio. If a line drawn parallel to the one side of a triangle divides other two sides in the same ratio. As in triangle POQ, ED is parallel to the OQ, then ED divides two sides PQ and PO in the same ratio, that is of PE by EQ is equal to PD by DO. So I am supposing this as a first equation. Similarly, if you take a triangle POR, in this triangle POR, DF is parallel to the OR. DF is parallel to the OR. So from the same basic proportionality theorem, we can say that DF line divides the PO and PR in the same ratio, that is of PD by DO is equal to PF by FR. That means PD by DO is equal to PF by FR. This is our second equation. And now we have to compare these both equations, equation 1 and equation 2. In the equation 1, PE by EQ is equal to PD by DO. And in the equation 2, PD by DO is equal to PF by FR. That means if you observe these two quantities are equal to the same quantity, that is of PD by DO. That means if from that we can write that PE by EQ is equal to PF by FR. So from this equation 1 and equation 2, I wrote that PE by EQ is equal to PF by FR. Now if you take a bigger triangle PQR, in bigger triangle PQR, EF divides two sides of PQ and PR in the same ratio. Why? Means as we got in triangle PQR, PE by EQ. PE by EQ means EF is divides the PQ in the ratio of PE by EQ, and EF divides the PR in the ratio of PF by FR. As these two are equal, then we can say that EF divides the two sides of triangle PQ and PR in the same ratio. EF divides the two sides of triangle PQ and PR in the same ratio. Now here I am going to make use of converse of basic proportionality theorem. Sir, what is converse of basic proportionality theorem? Means if a line divides the two sides of a triangle in the same ratio, then it is parallel to the third side. If a line divides the two sides of a triangle in the same ratio, then that will be parallel to the third side. That means as EF is a line divides the PQ and PR in the same ratio, from the converse of basic proportionality theorem, we can say that EF is parallel to the QR. EF is parallel to the QR. So from the converse of basic proportionality theorem, we can write that EF is parallel to the QR. Therefore, we proved that EF is parallel to the QR. Thank you friends for watching this video.